Hello everyone. Today we're looking at the problem maximum product of three elements after one replacement, which was question 2 in a weekly contest 474. So the question reads that we're given an integer array, nums, and we must replace exactly one element in the array with any integer value in the range of -10 to the 5 and 10 to the 5. After performing this single replacement, determine the maximum possible product of any three elements at distinct indices from the modified array. We want to return an integer denoting the maximum product achievable. So this is a pretty complex statement. I can understand if you're confused, but it's actually a pretty easy problem. So let's take a closer look at some examples. So here we see the example where nums is equal to -5, 7, and 0. And our answer here is 3.5 million. And the explanation is that we replace 0 with -10 to the 5, which gives the array -5, 7, -105. This has a product of -5 times 7 times -105, which equals 3.5 million. And this is the maximum product we can get after replacing any integer in this array. Let's take a closer look at an example. So you might be thinking that, well, let's try to brute force this. So how would we do that? So let's say that we're taking this element here and we replace it with just some integer, right? Let's say if we replace it with 100, and then basically what we do is do a nested loop for these other elements. So maybe we have I here and J here, and we'd have to compare all three of these elements together, get the product, and kind of compare it to the maximum we've seen. Obviously, a couple issues here. So first of all, we have to do these nested for loops right here. So I and j. So this is at least O of n squared, right? But remember that we don't know what value to pick exactly. We just chose 100 here randomly. But we could potentially have to try every integer from -10 to the 5 through 10 to the 5, right? So you can see that this is going to become really, really overcomplicated and way too expensive to do any kind of brute force solution. So how should we approach this differently? So really the solution to this problem is extremely simple. I'm going to put it here right now, and then we'll walk through some examples to explain why this works. What we want to do is we want to take the absolute value of the largest two elements, so that will be 4 and 3. And then we're just going to multiply that times 10 to the 5. And this will be our answer. So this will be 12 times 10 to the 5, which I guess is 1, 2, 0, 0, 0, 0, 0, right? So this would be our answer here. So why did I do this? Why did I just pick these two elements, the largest ones, take the absolute value, and multiply them by what seems like this arbitrary element here? So let's look at a couple examples to see how this problem breaks down. So let's look at a case where we have all negative values. So we know that what we have to do here is that we have to replace one of these values here with another integer. So let's also remember that if we take any two values, right, that negative values, and multiply them, they become positive. So let's look at our options here. We would have -4 times -5, which equals 20. We could also do -4 times -6, which would equal 24. We would also have -5 times -6, which equals 30, right? So just looking at combinations of two different elements, if we multiply them together, we see that these two would be the largest values if we took their absolute value, also give us the largest product. So it would make sense if we're trying to maximize product that we should try to pick these two largest ones to give us the largest absolute value, right? And now, see we have this 30 here. Let's say we're going to now work with this. So what number should we replace this with? Well, we could say, maybe let's try to multiply it by 1, multiply it by 2, multiply it by 3, and see what we get. But again, this is unnecessary. We know that our numbers can go all the way up times 10 to the 5. And there's no way that if we pick something smaller than 10 to the 5, it's going to give us a larger product than just picking 10 to the 5. So in this case, what we're going to do is just say, well, this is the largest combination I can get with two existing numbers, this 30. Let's multiply that by 10 to the 5. And that's our answer. And we can do the same thing with all positive numbers. So I won't go through the whole thing, but again, we have 4 times 5 is 20. Again, 5 times 6, this will be our largest pair, which is 30, times 10 to the 5 is our answer. So let's look at another interesting case here. Let's say that one of these elements is negative here. So you might be tempted to say, well, in this case, right, let's look at our choices. We have 4 times 5 equals 20. We have 4 times negative 6 equals negative 24. And we have 5 times negative 6 equals negative 30, right? So you might be saying here, well, now we have to take 4 times 5, right? Because this is actually the largest value because our other values are negative. But remember, we can do any value, replace any value from negative 10 to the 5 through 10 to the 5. So again, what we do here is say, this is technically our largest absolute value, this 30. So what we would do here is take this 30 and multiply it by negative 10 to the 5, right? Because that negative would cancel out and again would give us the largest possible product. So let's look at our final case here where we have a good number of zeros. So really in this case, our answer would just be 0, right? Because let's look at our options. We could do negative 1 times 0. When we do absolute value, this would be 0. We could do 0 times 0, which would equal 0. So either way, we're going to get some zeros. So if our two largest values here are 0, then again, we can't really do anything, so we're just going to return a 0 value here. So what is the time complexity of the solution? Well, you see it boils down to finding the maximum two values after we take their absolute value and then multiplying it by either 10 to the 5 or negative 10 to the 5. So we could sort, which is O of n log n, to get that value. And this is acceptable, but there is a better way. A lot of languages have a built-in n largest function, which Python does, n largest. And what this can do is allow us to get those largest values in O of n time, right? So we could say, get the two largest values from the list, and then we can just use those values in order to get our final answer. So this would give us O to the n, which is the optimal solution here. Let's hop over to the code and see exactly how this works. So this problem has very simple code. I broke this step out into 2 different lines. You probably could consolidate this, do it as a one-liner, but just for simplicity, I broke it out into a couple of different steps. So the first thing we do is we're going to go to the original nums array and just get the absolute value of each element. This is because we're really concerned with the absolute value of them, how far away they are from 0, rather than whether they're positive or negative, right? So we're just going to convert them all to positive numbers. Then we're going to use the n largest function to get the 2 largest elements from that nums array and call them a and b. And then since we have positive elements here, we know they're positive because we called absolute value in all of them. We just take a times b and multiply it by 10 to the 5. So let's submit and make sure that it works. And it does work. Hope this is helpful and made sense. If you liked the video, please like and subscribe, and thank you for watching.